Hello, this is Dr. Gardner. This is a brief discussion on how to name hydrates. Now, the first thing you need to realize when you have a hydrate is that we're going to expect these to be ionic compounds. And as you recall, with ionic compounds, we do not have discrete molecules we're looking at. We actually have an ionic lattice. We have a crystalline lattice, it's a crystalline solid, with organized arrays of the ions maximizing attractions between cations and anions with their ionic charge. That's through Coulombic attractions. Now, as we're looking at hydrates, we can imagine we have all these cations and anions in the ionic lattice, so it's like stacking a bunch of tennis balls and maybe soccer balls in a box, and as they stack together we have holes in between the spheres. Those are like the ions. Now those spaces in between the ions and the ionic lattice can have water molecules. And so when we write a hydrate, we're going to indicate how many equivalents of water molecules there are for every unit of the ionic compound. So as I start to name a hydrate, I'm thinking I need to specify the number of water molecules attached to each formula unit of that compound. Now in order to do that, we're going to have to use some of our Greek prefixes. We're also going to include the term hydrate as part of the end of the name. So I'll use hydrate with a prefix to indicate how many water molecules are associated with that formula unit from the ionic compound. It's really quite simple. If we take a look at it and we want to name some hydrates, we might consider the following compound. Now if we look at this, what I want to name first is the ionic compound I have at the beginning of the formula. And so if we look at the beginning of the formula, we have an iron 2 cation. I know this is iron 2 because in order to balance charge with the -1 fluoride ions, we would need to have a +2 because each fluorine has a -1 and there's 2 of those present in the formula. So I name that iron 2 fluoride. And then I would need to indicate how many waters of hydration are present at the end of the formula. So we'll see at the end we have a coefficient of 4 indicating 4 water molecules are present in the ionic lattice for every iron 2 fluoride ionic formula unit that we have present. So I'd write the name as iron 2 fluoride, and since there's 4 water molecules, I use the prefix tetra, just like we were using with molecular compounds, even though this is an ionic compound that's a hydrate. So I would name it tetrahydrate to represent those 4 water molecules associated with every formula unit. So we can do the same thing even if there are different numbers of water molecules present in the formula. So here we have an ionic compound with 6 equivalents of water for every formula unit. So I would name the ionic compound first. Here we notice that the chloride ions would have a -1 charge each, so this should be a cobalt 2. The cation should have a +2 charge. So I have a cobalt 2 chloride, and I use a different prefix in front of water. There's 6 water molecules, so I use the prefix for 6, hexa. So I would name this cobalt 2 chloride hexahydrate. Now if I had this compound, there's 3 water molecules, so I should be using the prefix in front of the hydrate of a tri, but I would name the ionic compound first. I know that this compound has lead. Pb is lead. We know that perchlorate is my anion because it has 1 more oxygen than chlorate, which would be ClO3 negative. Perchlorate would be ClO4 -1. Since it requires 2 of these to balance the charge on the cation charge must be a +2. So this would be lead 2 perchlorate trihydrate. Now some hydrates, if we heat them, we can drive the water out of the ionic lattice. So let's say I take this compound, it's my cobalt 2 chloride hexahydrate. I could heat it, and as it loses water, I could end up with a ionic compound, cobalt 2 chloride, that has lost the water molecules that were trapped in the ionic lattice. Sometimes we want to indicate this with a special name. We would call this anhydrous, an anhydrous ionic compound, or an anhydrous salt. To chemists, ionic compounds are considered salts. So I would name this anhydrous cobalt 2 chloride. That just means that there are no waters associated with the formula at this point. If we allowed the cobalt 2 chloride to absorb water again, if it had 6 water molecules again, we would go back to naming it cobalt 2 chloride hexahydrate. Now the reason we want to learn about hydrates, for example, is that we will be analyzing alum in our laboratories, which is a hydrate that contains a complex formula, which we will discuss at the beginning of lab, that also includes waters of hydration. We will study to see how many waters of hydration are present. So we will review naming hydrates at the beginning of that laboratory as well.